Hello, I think we should now be live. Yeah. Okay, hi everyone. Welcome to the first technical lab session. We're going to be going through the Unix shell today. Thanks for coming. Just a couple of things to run through first. We wanted to thank the department for their support. They've been very supportive over technical labs, and we're very grateful to them. And also, if any of you showed up to the previous session, we ran about half an hour ago for advanced labs, you may have noticed our camera quality is getting better. So you can read the board. We're working on our tech gradually as things are arriving. The department is also supporting our technology, so getting us some equipment. So thank you very much to them. And thanks for bearing with us. We're working on it. It's new to us. Thanks, Joe. Joe is running tech today, so thank you very much to him. Okay, and then we're going to move on to the technical lab itself. I'm gonna switch over here. Let's switch to here. Lovely. So Joe, if we could switch to Big Chef. So we are going through notes on this. We're going through notes. These notes are going to be made available. We're going to put a link out to you after this lecture. And so you can access the notes afterwards if you want to go through this. We've also put some exercises on there. So if you want to sort of go through what we talk about and increase, practice. If we look at this, you can see here's all the notes, and at the bottom we've got a set of exercises. And there's more detail in the notes than I will be going through. Sorry if that killed YouTube's compression. Okay. Are there any questions before we start? Big Chef and Little Chef. So we've got two. I don't know if you want to switch between them, Joe. We've got Big Chef, which is when I am large and the code is small. We switch to it. Yeah. And then we've got Small Chef, which is the one you had a second ago. And like any computer scientists, when we named something, we went for a joke, which is like 90% of the way things are named. Unless you're at NASA, in which case it's just, what's a funny acronym? Okay, cool. Any other questions before we start? Okay. Cool, let's get going. Okay, so we're going to be covering the Unix shell today, which I've got open here. But first of all, we want to sort of give you a very, very brief introduction to what Unix is. Unix is a very big thing, but we're not going to go into it in too much detail. When people say Unix, they don't mean one operating system. There's a whole family of Unix-like operating systems that derive from the original AT&T Unix operating system. The original Unix was written, along with the C programming language, in the 1970s by Ken Thompson and Dennis Ritchie. So it's not very compatible with software anymore. There are many Unix-like operating systems, Mac OS, Linux, all the different Linux distros being two of the most popular for the desktop, and iOS and Android dominating the mobile market. Unix is pretty much everywhere anymore. Unix-like systems are characterized by a very modular design, where functionality is made up of simple tools, and each tool performs a very well-defined function, which then combine together to make more complex functions. So the entire OS is built up of small building blocks chained together, along with a master control program, the kernel, which controls things like starting and stopping programs, file systems, and other low-level tasks that all the programs share. Unix was instrumental in the development of the internet. I believe the World Wide Web was made on a Next machine, which is a Unix. Next Step was the operating system, and that was Unix-based. And the internet is still massively run on Unix. Probably over 90% of servers worldwide are Unix-based. Switches, everything runs on Unix. They're all Linux-based. And yeah, so the vast majority of machines make up the internet run Unix. Okay then, we've got the Unix section. Oh, So what is the shell section of this? The shell is a program that runs on Unix, and it makes the shell is the command line interface for interacting with Unix. So on some computers you'll have a graphical interface, a GUI, on the vast majority nowadays. But there's another way of interacting with computers through command line interfaces. And shell refers to both the language used to input commands, so the syntax for inputting commands, but it's also a scripting language, so you can write entire scripts in this same command-based language. Cool. Okay, when Unix was first made, you tended to have a big computer machine and then a separate machine that put in commands and retrieved the output of commands, or was sent the output of commands. We don't do that anymore. It's quite difficult to carry around a big server with you. So we tend to have the machine be the computer and then have a terminal emulator to emulate the old terminal machines. I have one open here. You can see. So this varies computer to computer what it's called. On Mac, the default one is called terminal.app. On most Unix distros, I think it's just called terminal. I'm not certain. And Windows, everything's more complicated with Windows. I'm not sure. And so when you enter commands into a terminal emulator, it passes those commands to the shell to run them. And those commands might request some built-in functionality of the shell scripts, or installed programs. The output of the command is then sent back to the terminal emulator and displayed on your screen. The most common shell is the Bourne Again shell. Bourne spelt B-O-U-R-N-E, I don't know what it stands for, or Bash. Again, computer scientists like their acronyms and jokes. The shell... But shells like the Z shell and the friendly interactive shell, so Zush and Fish, are gaining in popularity. We are going to be using Bash because it's by far the most popular and most compatible. Okay, how is it going? Is everything all right?
Arthur's come to join.
Arthur's here. Hi, Arthur. Okay, I think we're okay.
Yeah, all good.
Okay, how to get a Unix-like command line on your computer. So you may be wondering how to open up a command line. I'm sure a lot of you have already done it, but some of you won't. For Mac and Linux users, the answer is very simple. You're already running a Unix-like operating system, so install the terminal emulator of your choice. I'm using Alacrity. And you're already off to the races. Or use the pre-install option. For Windows, the answer is always more complicated. Windows is not a Unix-like operating system. It originates from the Microsoft Disk Operating System, or MS-DOS. And so it doesn't have a Unix shell. It has the PowerShell, which isn't very widely used, isn't compatible with most Unix tools. I don't know if anyone really uses it. I'm sure there's someone out there who likes it. But all is not lost. With Windows 10, and more so recently, Microsoft has added a feature called the Windows Subsystem for Linux, or WSL, which allows for users to use a Unix shell, like Bash, and almost all of the GNU utilities that make up Linux, without using the Linux kernel. So basically, it allows you to use an Ubuntu, I'm not sure how to pronounce that, Ubuntu? An Ubuntu system within Linux. It's almost completely compatible, but just that kernel, that central functionality, is controlled by Windows rather than being an OS of itself. Oh, and yeah, cool. There's a link to set up the WSL if you go to the notes. It's pretty simple. It's all, it's supported by Microsoft, so it's pretty good. And then you can just install Terminal Emulator of your choice, and you're going again. Cool. So, how to use the Unix shell. Let's stop there if anyone has any questions. How are we doing for time? Are we doing
to the notes.
Yeah, sure. Do you want to stick the notes in?
Sure.
See you later, Arthur. Sorry, you guys are down here for me, so I'm looking down there.
So I'll stick the link in the Teams and the Discord and in the chat.
Yeah, WSL2 has just come out where the kernel isn't emulated through Windows, it's actually a virtual machine, as a Linux kernel running on a virtual machine. Just look up support articles and run whatever is the most supported option for Windows. Okay, cool. Right, lovely. So let's move on to how to use the Unix shell. So when you open up the terminal, which we've got here, you'll be presented with a prompt, which is I'm pointing at, which you guys can't see. Is this thing here? It may look different. You can customize your prompt to however you like. It's amazingly customizable, and this will be where you write commands. The dollar symbol here tells you that you are you're not the root user. If you're the root user, it's a hash. And the little tilde here tells you what directory you're at. We'll get to all of that later. There are a few things to be aware of when you're using a Unix shell. The main two things you've sort of always got to keep in your mind is who you are and where you are. So, where you are. The where you are is what directory you're in. In a Unix shell, you always have a working directory. So you're always in a directory, and to find the directory, use the pwd command. So you can see at the moment on my Mac, I'm in the /users/Alfie Richards. And when you start a new session of Bash, you'll normally always be in your home directory. Each user has a home directory, and the home directory is you can always find the home directory because there's a shortcut for it, which is the tilde key, which is this key here. And that is why we've got that tilde key in the prompt. That is showing me that I'm in the in my home directory. Lovely. Pardon me. Didn't have to sneeze. Okay. And then, so to move around to different directories, you can use the cd command or change directory. So let's change directory to /users. Cool. And now we can see that because we're no longer in the home directory, it's printed out the file path the directory path I'm at, which is now /users, because that's where I've gone. And then I can go back to the home directory by going to cd tilde, which is the shortcut for the home directory. And if I print working directory here, you can see I'm back in my home directory. Cool. You can either give cd a relative path or an absolute path. Relative paths start with a /. So as you can see here, when I did this, that's a /. That's going to go from the root directory, which is just the very base of a Unix file structure, into then to its subfolder users. But we can also do a relative directory where we don't have a /. We just put the name of the folder we want to go to, in this case, my user folder. And it goes from your current folder, so in this case users, and just adds this file path on, and if that's a valid directory, it will go to it. Cool. As you can see, we're back there. Lovely. Okay, so now you know how to move around, change your working directory. But you can also may want to see which files and directories are in your folder, the directory you're in, sorry. And that's done with the ls command, which is short for list, and here you can see all the folders that are in my working directory. Thing is about Unix is it does like to lie to you. So here you can see this is a lovely number of folders, but if I do ls-a, you will see a ton more folders, which are all any folder that starts with a full stop, or just a period, I think it's called in American, is hidden by default, and the ls-a says ls, and then the -a flag means all, so list all. If we go back to users, and I do ls, you'll see all the users on my account. And if I do ls-a, you'll see some more folders show up. .localized is some internal macOS thing, I'm not overly concerned. And then you've got this ... and this single dot. What are they? Well, they're not actual files in this directory. Unix puts these in every, maybe it's Bash, puts these in every single directory. The dot means the current directory, and the dot dot means the parent directory. So here, if I do something like, so ls can also take a file here. So if I do ls, my home directory / documents, this will list the files in the documents folder. But if I wanted to do that for the current directory I'm in, I could just do ls dot. And this will list, because the dot represents my current directory, this will show my current directory. If I wanted to show my parent directory, then I could do dot dot, which is the parent directory, and that shows what's in my parent directory. So let me go back to my home directory. And so we can also, combining cd with the parent directory, we can do cd dot dot to go to the parent directory. Now you'll see I'm back in the users. Okay, how's that? Am I going too fast or? Okay, people seem okay. Yeah, we all happy? All right, lovely. Let's move on to who I am. I'm not going to be able to do this on my Mac, so just ignore what I'm doing here. Joe, do you want to pull up technical difficulties?
Oh, good. Yeah, so we've got a technical difficulties slide, which we wanted to use. We don't actually have any technical difficulties, but...
Well, okay, and we're back. Sorry, ignore what just happened. There was a lot of hand waving. I'm connected to a different machine now. Don't worry about how, but we are connected to a different machine. And you can see on this machine, I'm currently alfgalf. This is my user here. So you see alfgalf. The rest of it is the same. We're in my home directory, and we're not the root user. We're alfgalf. And so the who is what user you are. You always have a user in Unix, I think. You can't say anything about all Unix because there's so many different distros out there. I'm sure some of them don't have users, but all the ones I know of do. And so you can use the command who am I, which will tell you which user you are. Very helpful. This is what they use to get the name in your prompt. Cool. You can then change users by using the su command for switch user, I believe. Then we can switch to root. Okay, and now I'm root. Okay, so, and you can see in the prompt it's changed, and you can see the $ has changed to a hash, and you can see because I'm not in the root's home directory, it can't just use a tilde. It's have to use the whole file path because we're not in the home directory. Cool. Root is like the administrator for the whole computer. They have ultimate powers over your computer. Some people like to run as root for everything. Joe. But you really shouldn't. On Macs, it's reasonably difficult to switch to the root user because you have powers over everything, which means certain things which you are very, very destructive, you can do without any checks. Because you're a root user, you can just do it. Which isn't great. You can accidentally do some very damaging things, which we really don't love. So most of the time, you just stay as the, oh dear. You just stay as a user, and if you need to run a command that demands to be, you need root privileges for, you tend to use the sudo command. I don't know what sudo stands for. Anyway, what sudo does is you give it a command, and it takes that command, and it runs it as the root user. So if I do sudo who am I, then it will require
super user do.
Super user do. Cool. I think it's going to require this password, right? Yeah. Cool. and then if I run that, so running a sudo normally prompts you for some kind of password. With the way I've got this computer set up, it's asking for my user's password. And then it will run. And here, because I ran who am I as the root user, because I did super user do, so root ran who am I, it returned root rather than me, rather than alfgalf. Cool. Okay, so that's the where and the who. Now we're going to get on to the basics of how you structure commands in Unix, and to some actually using Unix. Any problems?
All seems good.
Cool. Okay. So let's go through the basics of Unix. So, each command in Unix is structured in a very specific way. Let me... Cool. Ignore that. We'll get to that in a later date. So we are going to type a command here. It's cool. It's a Mac specific command, I believe. Cool. So we've got a command. I'm going to run it.
Hello, Technical Labs.
Hopefully you heard that. Hopefully it wasn't too loud. So the say command. So macOS has a built-in synthesizer for people who are what's it called? For accessibility. Sorry, I had a complete mind blank. For accessibility, and so you can go into voice-only mode. But it also means there is a Unix command to just synthesize. So here I'm running the say command, and then I'm giving it a parameter. So each Unix command is structured as the first word separated by spaces, the first string separated by spaces, is the command. And then it's got a bunch of parameters which are all separated by spaces. So if you've done any Python programming or Java programming or C programming, you'll normally know that the main entry point for the program has an array of strings. It's called like args. You've probably never used them, maybe you have, I don't know. And that's what this is. So here, if this was your program, if say was your program, you would get one string that said hello technical labs, one string that was -v, and one string that was Alex. But so you could just take whatever you wanted, but there's a lot of common practices. It's also important to note that because I surrounded this here with speech marks, the speech marks are removed, and then that is input as one parameter. So that would just be hello technical labs with these spaces, whereas everything else, if there's a space, that separates it into different parameters. So here, the say command takes a string, and it will say that, and then I've done the -v flag. This style of parameter is called a flag, where it's a hyphen, then some letter, or sometimes it's -- and then a string. So it would be like that, and then so we could do -- voice Alex, if you wanted to. And then Alex here is which voice I wanted to use. So there's lots of different voices. You can choose your preference. I went with Alex. Cool. There are a bunch of different commands in Unix, and they sort of fall into three categories. There are internal commands. So internal commands are built directly into the shell, and the shell directly interacts with the OS, and no other executables are required. So something like cd, change directory, the shell just manages that. There are also included commands. So these commands are bundled with the operating system and basically make up the operating system. macOS is built up with tons and tons of libraries that all make macOS what it is. If you didn't have them, it would be usable, but barely. So anything like networking, anything. This say command, for instance, is all an included command, so it comes automatically with the operating system. Then there's external commands, which you add yourself, or other things add for you. There's multiple ways to add commands. If the command comes into the first category, where it's an internal command, the shell does this itself. It talks to the kernel and manages these commands itself. Nothing else gets run most of the time. Otherwise, the command has to go and run another program. And to run the shell has to go run another program. To do this, it's got to find the file where your program is, and it does this pretty simply. It has certain directories, certain special directories called the path directories, which are stored in the path variables. We'll get to them later. And it goes and looks for executables, in most cases binaries, with those names. Okay, so literally this say command is looking in certain files for a binary that is called say. And you don't have to leave this just to be, we'll cover path variables later. But you can discover either where the program is or what type it is by using the command type and then the command you want. So here, you can see say is hashed in this case in user/bin/say. We won't get into that, but if I do something like type echo, you can see echo is a built-in command, so it's just part of the bash. And type something like .NET, which is something you use for running C# code. It will tell you exactly where that binary is. And if we go to this path, we will find this binary. Lovely. And that will tell you if the command either falls into the first category or into those joint 2 categories at the end. And you'll see that most of the time these binaries are stored in a file, and one of the files will be bin. Bin means binary in this case, so that's a file where binaries are stored. Cool. So the next thing we're going to cover is different commands take different parameters in different orders. And this is scary. Where do all these commands, how do you know which command to use? How do you know which parameters it takes? How do you know in which order? Thankfully, commands come with manuals. How do you find these manuals? Well, they're very rarely called manuals. They're called the man pages. Why are they called the man pages? Because the command to look for them is man. So man, and then the command you want. So in this case, we'll do man.net. We're not going to do man.net because there isn't one. Good. Man Javac. Most commands have a man page. Man echo. Here we go, a man page. So a man page comes with, so it has the name, the synopsis, which is which order you enter parameters and which parameters they can be, and then a description. So it describes all that the command does, and it gives you a description of each one of the flags you can add. You scroll these pages with either the arrow keys or by pressing D and U for down and up. And you can see they're normally fairly verbose. They're very nice manuals for each command. Some commands have tons, some commands don't have very many. To exit these man pages, press Q. That's from an editor called VI. It's not overly important, but Q is what exits them. I've seen lots of people very confused. Some commands are built into Bash and might not have man pages. Bash has a built-in command called help for all of its built-in commands. So if we do help cd, this will give you a description of cd and how to do it. So feel free to read them every time you want, you're confused about how a command works. The next question might be, how can you find the commands? Because sure, it's great if you know what command you want to use, you can look at the man page. But if you don't know which command to use, then you're still lost. There's stuff for that as well. You can search the man pages. So man-k, and then a keyword you're looking for. So in this case, let's search for compiler. There you go. And here you'll see every single man page which has that compiler in its little description. So for the vast majority of the time, this will find you the commands you need, and you can look through these to try and make sense of what each command is. Cool. Let's move on. Okay, so now you know the basics of how commands are structured and how to find how they're structured. So we're going to move on to file management and just some basic file management in Unix. Are there any questions at the moment? The chat on the small display isn't scrolling anymore. Or maybe it is. Oh yes, it's just not any questions. Any questions? Are we going at a reasonable speed? Is everyone okay? Okay, lovely. Right, file management. So, if you like a Unix shell is a way of interacting with your entire computer. It's another way of controlling your computer. So you've got to be able to do things like file management. You can do pretty much everything in a command. Well, you can do everything in a command line, one way or another. So let's talk about how do we make directories. So currently I'm in my home directory, and we might want to make another directory to store some stuff. So we can do something like make dir, so mkdir, which is make directory, and then we give it a name. So let's call this technical labs dir. Okay, and if I ls, you will see, okay, we've got lots of technical labs here because I was working on this yesterday. But if we go into our technical lab, if people are wondering how I'm making text magically appear, in Bash, the tab key tries to do auto-completion. So if it can if there's only one option for what you could be typing, it will try and fill it in for you. It's not perfect. It's much better in things like Fish and Bash. And Zush. I don't know how to pronounce that. Z shell. But yeah. So now we can make directories. But what if you make the wrong directory, or you make it in the wrong place? So let's make another directory. Just call this one folder 1, and another directory called folder 2. Okay. Cool. Okay, so now you can see I've got 2 folders in this directory. But what if I wanted folder 2 to be inside of folder 1? Then we use the move command, or mv. So move takes the... The move command is a little bit complicated because it doesn't just move folders. What move does is it changes the file path of one item in the file system to another file path. So here I'm going to, the first parameter it takes is the thing you want to move. So in this case folder 2, and then you say what file path you want to move it to. So here I'm going to say folder 1. So this, I'm saying, please take folder 2 and change its file path to be folder 1, but because folder 1 is a directory already, it's going to know that we mean put it inside folder 1. Okay, so now the current directory we're in is empty, and if we move into folder 1, you see my directory changed, you can see folder 2 is in there. So this means you can do a lot of things with move. So for instance, you can also move files. So here I've just made a folder called text.txt. It's empty, but ignore the touch command, or that's left as an exercise for the audience. So text.txt. So we can also move files. So in a file directory, there are directories and there are files, and some other stuff, but those are the 2 main bits. The main things you'll find. So we can move text.txt to a file, to a folder. And then if we move into that folder, you'll see we have text. But we can also move the directory of that file to another file directory. So let's move text.txt to new text.txt. So new text.txt isn't a directory. So what it's going to do then is it's going to change the file path for this folder to this new file path I've specified, which are both relative file paths. So So here, if I list, you'll see that file has its name changed to new text.txt. And you can do the same thing with folders. So if I go to the parent folder, which will take me back to folder 1, I can move folder 2, and I want to call it old folder. Okay, and if I list, you'll now see it's called old folder. So there's a lot you can do with the move command. It sort of serves four jobs. Cool. Any questions about that? Don't think so. Lovely. Okay, deleting files and directories. So now we've made directories, we've moved them and renamed them, but eventually we will want to delete them. So to delete folders, we use the remove command. And then we give it a file path. So only files here. Let's cd into old folder. So here I have new text. And I'm going to clear that. And so I'm going to ls just so it's nice and clean. So here we only have new text. And I'm going to remove new text. And it's gone. And this isn't like your normal GUI delete. This is Unix delete, where delete means delete. This is gone. The only way to get it back would be to like look at the raw bits on the drive and like try and recover it. There's no way in Unix to get this back. To remove directories, so let's go up to a directory, and we've got old folder in here. You can rm dir, so remove directory, and old folder. Cool. But this will only work for empty directories, because it's just removing the directory. So if you try to remove a directory with stuff in it, where does that stuff go? Because you're not trying to remove that. But there is a way to remove a directory and everything in it. So if we, again, I'm using this touch command, don't worry about it. You can go and look it up yourself. Okay, so here you've got text.txt in there, and I'm going to cd up, and then I'm going to rm-r, so that means recursively, so delete a directory and then everything in it, and then everything in them, recursively, folder 1. And that means everything is gone. Again, be very, very careful with this. It will just delete everything. On Mac, I tend to use a command called rm-trash, which will delete something the same as rm, but it won't actually delete it, it'll move it to the trash. So that if I do it by accident, I can go and get it later and it'll be emptied out eventually. But because rm is just a little bit forceful, you can very, very easily make mistakes. I think every Unix user has stories of when they've made mistakes with rm. Cool. And then the last thing to do with file management is copying. And copying is very similar to moving. You use the cp command, which just means copy. And again, so let's cd. Cool. Let's copy. We're going to copy the technical labs. So in the parent directory, /technical labs dir. So that's the folder we're currently in. We could have just used a full stop instead, but I'm doing it this way to try and show clearer. And I'm going to copy that into my current directory. So I want it to be called technical labs. Oh, I don't know if I can do this actually. Yeah, I don't think I'm allowed to do that. Let's go up a parent directory and we're going to copy technical labs dir, and we're going to copy it to do I have to specify recursively? Oh, okay, I do. I think this is where one of the things where bash differs from the Z shell. I use the Z shell, and I'm pretty sure I don't have to specify that. But here I'm just saying copy recursively. And if I ls, you will now see technical labs directory and technical labs copy. 2 folders. Cool. So now we're going to circle back to the path variables we talked about earlier. They were very mysterious. If anyone Okay, so someone here is posting about sudo rm-rf, which people like talk about. Sudo rm-rf means superuser do, remove, dash recursively, so do it recursively, and f means force. So for certain directories, if you try and remove them, it will stop you and say, you probably shouldn't be removing this. But if you really want to, you can force, and that will just not give you any warnings, it will just do it. So it gets passed around on the internet quite a lot as a joke. I don't know if anyone's ever fallen for it, I'm sure they have. So this will delete from whatever directory you specify, everything part in that directory, without any warning. Don't do it. Again, I recommend using something like rmtrash or some equivalent on your operating system, because you're much safer. Okay. Cool. Let me tell do not stop. Okay. Earlier we said the shell was a scripting language, so we're going to talk about the path variables now, and just variables and the environment in general, not the environment outside. Although it is worth talking about, we're going to talk about the environment as we mean in Bash. So, Shell is a scripting language, which means it's a programming language. You can write programs in Bash. I wouldn't, but you can. Or not a big part of any program anyway. I definitely wouldn't do competitive programming in it. And like any program, it needs variables. It needs a way to store data. And so there's a command, export, and then you give it a name. So let's call this technical labs. Okay, and then we're going to give it a value. So equals, we're going to make it equals so we're just going to give it some information to store. So technical labs test equals a variable data. Lovely. And now, if we want to get that data, we can use a command called echo. All that echo does is it takes in a parameter, and then it puts that out to the standard output. We'll talk about standard input and standard output later, but for now, don't worry about it. So here, what we're saying is echo $technical labs test, and whenever Bash sees a dollar, it will then assume what's coming after it is a variable and unpack that variable. So here, it's seen technical labs test, so it's looked in its variables, it's found this variable, and so it's printed it out. Lovely. Yeah, and so we can also do stuff like echo, and that will just print out the parameter we passed in. Lovely. All the variables together make a environment. So the environment. So currently I'm in a Unix environment, which is all of these variables together. Because programs can read variables, they can store settings in variables, and then you change those settings. It's another way of getting data into a program. So one way this is often used is, so say I have a website, for example, and I need to store the files for that website somewhere, like the files that make up that website. I can have a variable that stores the root, like the path for those files, and then when I run the program, it can just go look in that folder, find those files, and then present them when someone tries to visit my website. Cool. And so the path variables are just a very special variable, like any other, and Bash reads these. Okay? So if we echo $path, this prints out my path variables. I have lots. This computer has a lot of craft on it. Is there a question? Where are those variables stored? So those variables are stored, as far as I'm aware, I may be wrong, those variables are stored in memory in Bash. So when you kill Bash, so when this Bash session ends, these variables will die with it. They're not stored session to session. So the way you would then have a variable the same for every... So, okay, we're going down a little bit of a tangent, but there are a way to configure bash. It's called .config files. And if you need, so like all these path variables, these get added in those config files every time, so that they're there for bash to go look in. And so, well, I'm not sure that's true for path variables, but for most variables, they're stored in these config files. But most variables are just stored in memory in bash. Bash is just a program and it stores in memory. Lovely. So it's going and looking in these folders. Cool. So this is a big, so these are path variables. Path variables are a big list of directories where the shell can look. And so when I run a command, it just looks through every one of these folders for the command. And if it finds it, it tells you. If it doesn't find it, if it finds it, it'll run them. If it can't find it, it will complain. So if I try and just write some rubbish, it will say this is not command. So it's gone and searched through all of these folders, didn't find anything with that name, didn't run it. But if we use a command that, let's use the say command again. Okay.
Hello.
So if it finds the correct command, it just runs it. And if we want to know where that command is, we can use the which command, which just prints out the path of that binary in this case, or executable. And we don't have to get bash to do this work for us. We can do this work ourselves, or we can, or if the binary we want to run isn't in any of these path variables, we can just run it ourselves. So for instance, instead of running all of this, I can just say -user -bin -say and run the same thing.
Hello.
And so here, bash isn't looking this up. It's just going directly to the path variable we specify. And so this is useful for when you, I don't know whether you've done it, first years have done it yet. I'm sure, I know that second years did, if there's any here. Anyway, we'll get to that later. Sorry, lost my train of thought. We can specify commands that aren't in the path variables. So say we write some C code and then we compile it, and so we have a binary. We may want to run that binary. I don't know if I have any C code in this computer. Let's not make any, that'll take too long. But you could just run, so dot, which means go to the current directory, / and then the name of the binary that you've just compiled. And that will run your binary, and then you can specify any parameters you want as input. Lovely. Okay, I've seen some questions. Okay, are commands case sensitive? I believe so. Maybe not. No, it appears not. That may be a bash specific thing. I don't know. I imagine if you did a direct path, so if I do no, it's not case sensitive.
I imagine things like path variables or environment variables would be.
Path variables definitely are case sensitive, but commands themselves apparently not.
Someone tried echo in all caps and it didn't work.
Okay, it may vary shell to shell.
Yeah.
Apparently Bash does it, maybe Fish or Zush doesn't. By default, Macs come with Zush. So I don't know what's working. Just use the lowercase. Nearly all binaries are lowercase. Nearly all commands are lowercase that I know of. Maybe because of this reason. Okay, and so now you've seen how to run commands, which is useful somewhat, but earlier I said that Unix works by chaining commands together. These commands aren't that useful on their own. And the way you can... so you chain commands, you want to chain commands together. And the way commands run is, so, you know earlier I said you used to have a terminal emulator, and a terminal and the computer itself. And when you typed on the keyboard, that sends data to the computer. And then when it wants to print data back, it comes back. The program wants to send data back to you, it comes back. And bash is just a program like any other. And so the way this happens is you have a standard in, and each Unix program has a standard in and a standard out. It's written std in, and std out, normally. Okay, and so what bash is currently doing is it's reading my command input, and so any input you type on your keyboard is displayed on the anything I write on my keyboard is sent to bash through the standard in, and then it can send stuff back to me to be displayed on the standard out. Okay, so because bash is very nice, when I type stuff in, it automatically puts it on the standard out so that I can see it, right? I can see what I've typed, and it puts the prompt there already, and so you can read it. So all this text here, this Alfie Richards : $, is what bash has sent to the standard out, okay? And when I'm typing, I'm sending stuff to the standard in. And when bash runs a command or a program, it hands those standard in and standard out to that program. So, and they can do pretty much whatever they want. So if you've ever written a Python program and run it in the command line, or anywhere really, if you've ever used input and print, what input does is it reads a line from the standard in. So that's just whatever the user types until they press enter. And print just pushes whatever string you want to the standard out. Input also, yeah. It's not quite that simple, but pretty much. And obviously we don't use terminals now, we use terminal emulators, but this is what the terminal emulator is doing. It's taking your keyboard input and sending that to the standard in. And then whatever output it's pushing to the standard out. Cool. So you can then, but you don't have to have the standard in and standard out comes from these places, right? Certain commands take data from the standard in, and we can. Right. Let's just. I'm going to make a directory. Okay. So I made. Okay, I made a new empty directory, right? And so say we're running a command that puts out loads and loads of logging data to the main program. It's just, you don't want it all there, really. You want to be able to look at it later. You don't want to look at it all now. You can use something. So I'm going to use echo. Echo doesn't make loads of logging data, but imagine it did. All this would normally pipe out to the standard out is hello, right? But what we're going to do is we're going to use this operator here. It's the right caret. And we're going to specify a file. So text.txt. Spell check myself. Okay, and this is going to take the output here and put it straight into text.txt. And once the program finishes running, it will save the file. Okay, so you can't see anything here, but here's the file. Okay, and then I can print this command. So cat concatenate. Does it say? Don't know what the cat command's written for. I did know at one point. I think Joe's looking at concatenate. Okay. Oh yeah. So you can cat, and this takes a file. So cat reads in a file and just prints it directly out to the standard out. So it just reads in a file line by line and outputs it to the standard out line by line. So you can see here, this operator took the standard out from this command I ran and put it in text.txt. We can also do the reverse. So say, so the echo command, if you don't give it any parameters, no, what am I talking about?
Yeah, if you don't give it any parameters, it doesn't print.
I think. Can do that. No, you can't. Never mind. What am I thinking? Am I thinking of cat? Yes, okay, sorry. Right, okay, so the cat file, if you don't give it specify a file, it will just read whatever you type into the standard input. So here, I haven't given cat any file to read, so it's just reading the standard input, which I've written to. And as soon as I press enter, so I put a new line character in, it's going to read that and put it to the standard output. So, okay, it's just going to copy as far as long, and I can stop that by pressing Control C, which just killed the command. Well, it gives a stop command to the program. But so here I can, but say then I can feed in text.txt. This isn't very useful in this case because I could just cat text.txt. But say you had a Python program that stripped out all full stops of a folder, right? You could feed in that file to the program and then take the output and save that to a new file. Okay, and then if we... Okay, you can see that it read in text.txt to cat. Cat just simply read that out and spat it back out again. And that got added, that was sent to new text.txt. But what we can also do is so this is the send to command. I don't know what it's properly called. I'm calling it the send to command. You can also do an append command, right? So this just adds this file, the text you're adding to the bottom. So say you had a log and you wanted to keep using that same log for each program, each time you ran your server or something, you could just append the new logs to the end of that program. So here, if we look at new text.txt, you can see it added the output of running the command again to the end. Much more useful. So for an example, let's if I run .NET without any parameters, it lists out how you can run it, which is a fairly long command. Imagine this was reading out reams and reams of data that I didn't want. I can instead add that to .netlog.txt. You can see it's made .netlog.txt. And then if we wanted to, we could then do something like, so nvim is a text editor. So it's a command line based text editor. So then I can just go and look at this file and you can see it's output that normal, whatever it was going to put into the standard out, it's put it into this file for us. Cool. Cool, I'll just delete that. So then, this is very useful. But there are more things, there's even more things you can do with this. So this is great for reading stuff into and output files, right? But you can do more. You can connect one program to another. We talked about this earlier. So again, with this .NET command, say this .NET command had a ton of output. So actually, we've got a better example. ifconfig. ifconfig is the command you use to list, at least on Macs, I'm not sure what command to use on different operating systems. I think it's the same. ifconfig lists loads and loads of data about, maybe you shouldn't be seeing this, I don't know. Let's quickly clear it. Don't DDoS us. Lists loads and loads of data about your current network connection. Okay, so it lists my computer is connected via Ethernet, it's connected over Wi-Fi, it's got, I'm sure you can connect it over Bluetooth somehow, it could be connected over USB, and so all these things, it's got chips that are doing this, and so ifconfig just reads the state of all these chips. You can find your IP address and things in there. But as you saw, it's quite long. And so say I don't want to know all that, I just want one specific thing, so we can pipe that. So a pipe takes the standard out of one program and then feeds it into the standard input of another program. So here I'm using grep. What grep does is it searches for certain strings, and if it finds a certain string in any line, it then prints that string to sends that string to the standard output. So here, say I want any line concerning 127 dot. Here you go. You'll see that one of my things has a net mask for 127.0.0.1, which is localized. Yeah. Cool. So here you can see I filtered, and again, this command's relatively useful. But say you had a thing that you had a file with thousands and thousands of emails, and you just wanted the email for your friend Joe. You could just grep Joe, and then it will print any line that contains the word Joe. And that's just the grep command. You can send different commands to different places. So there's also the tail command. Oops. Okay, and so the tail command just prints the last few lines of your standard output. Here I've specified with a flag one line, and this is the last line of ifconfig. The way this works as well is it doesn't wait until the first command is done and then feed it to the second command. It feeds in line by line. That may seem like some sort of very pedantry thing, but imagine you had a command which took data from the internet and just continued spitting it out. So say like every time someone sends me a message, output some data. Okay? Then I could have another command that every time it gets some data, pops up a notification. And then every time someone sent me a command, it would send me a notification. So let's just imagine it would be something like message receiver. This is not an actual command. Okay, and so this will receive messages. It just listens to the internet for some messages for me. And then I'm going to send the output of that. So say that every time that received a message, it said like, message from Joe saying whatever. And then I pumped this into Notify, that every time it received something, it just popped up a notification on my computer that said, you've received a message. And that won't wait until message receiver is done. Every time message receiver has some output, it will send it directly into Notify, and Notify will get to do whatever it wants to do. This is also useful because you can do things like some commands allow you to open network sockets. So you can open a network socket and then pump whatever data comes into that data socket to a different program. And this is how you can do things like if you have a camera on your network and that camera is sending out data to this socket, you read in that socket and send it to some program which shows you the video. Cool. Okay, so that's the last thing we wanted to cover. Are there any questions on that?
IP config on PowerShell.
Thank you, Thomas. Okay, cool. All right, so hopefully we've shown you how to move around the shell, how to do some basic file management, how to change which user you are, accomplish a few basic tasks, and like a few of the basic concepts of Linux that you can then use to move on to do other stuff. There are lots and lots of people who love Unix out there who post massive tutorials and videos online, and so you can go a long way just reading tutorials and learning stuff online. And hopefully we've just introduced a bit of basic terminology that you can then, so you can understand the data you get on the terminology they're using in these tutorials. And we really encourage you to go and learn more on your own. Unix, all the stuff we've done today, none of it was overly useful. All stuff you could do with the graphical user interface. But there's a lot more commands that you can't do with a graphical user interface. And like if you're running a server, most servers don't have graphical user interfaces. You connect directly to their shell and run commands in their shell, and that's how you manage a lot of servers. And I'm sure there are GUIs, but they're not going to have all the functionality, whereas with a command line, you can do everything. So go out on your own. Try every time you maybe a couple times when you're trying to do something on your computer. Try and find a way to do it with Unix. Use the man pages every time you're confused about a command or you've forgotten about a command. Just look up the man page and have a look at it. Man pages are your friend. But Unix is massive. The shell is massive. We cannot cover everything in it. Hopefully you've learned something today. But in future we're going to cover some more things in technical labs. We're going to cover Git, which is a command line utility, mostly for some people. It was primarily written as a command line utility. But we can't possibly cover all of Unix. You have to go out on your own and discover Unix and do stuff to discover it. But there's a very supportive community online, man pages and help pages. But yeah, if you want to just get a bit more comfortable with Unix, if you look at the notes, we've done a few basic exercises you can work through. And then, a few last things. There's some credit to be given. So I wrote the notes for this lecture. Not lecture, lab. I'm not a lecturer. I wrote the notes for this lab. Joe edited them for me to make sure it was all coherent English. And we sent the notes out to be fact-checked by a few of our friends. And so Dr. Russell Bradford is a lecturer up here at Bath. And Benser, who's a third year, he's currently on placement. And Soren, who is also on placement. There's also a place to send any corrections. I'm sure we got some stuff wrong, so please feel free to send us corrections there. And I hope this was useful. We will see you next time. I'll stick around for a few more minutes if anyone has any more questions.
Also, we'll be sending out a Google Forms, which will be like a feedback thing. We'd really love to hear some feedback from you guys, because we want to kind of
absolutely
change this up if there's anything that's not working.
Yep, if there's anything. And also, I'm pretty active on the Discord. We'll both be on the Teams. Have any questions, feel free to send a question on the Discord or specifically DM us. If there's anything that's been confusing, please feel free to send us questions. Let us know if we can help. If we went through something too fast, pretty much everything is in the notes. If you have anything to say about our streaming setup, it's been alright. We didn't use the whiteboard at all. I love the whiteboard. Yeah, lovely. Yeah. The setup needs more RGB. We do have a lot of RGB around.
There's actually RGB built into that table just there.
Yeah, you can't see it. There's some RGB sticking out here that we had set up, but if we turn the RGB on, it completely backwashes me. Thanks everyone. Thanks to the department for supporting this. Thanks for showing up. We'll be in Discord chats for the next half an hour if you guys want to send us any questions specifically.
And we'll leave you with a GIF of Patrick.
And we'll leave you with our technical difficulty screen because we love it so much.